we are going to talk about the operating system, especially the process management. So we are going to discuss about the process management as we discussed a lot of the introduction of the operating system and operating system architecture, computer system, computer architecture. In this class, throughout the semester, we are going to mainly discuss about the three topics. One is process management. Probably process management will cover the half of the operating system. Most of the textbook allocate the half of the chapter for the process management because the process itself is the everything actually for the operating system. Then followed by the memory management. Memory management, we try to share the efficiently. Also, we try to maximize the usage of the memory to speed up the process. The last one usually is the file management. We need to take care of input and output device. Okay, so today we are going to start for the process management. By the way, what is the process? I asked them many times already. So what is a process?
Manage of a program.
It's a program in the memory. Okay. So this is the basic, the computing architecture and operating system. The architecture, once you download or compile or whatever, so you have the program. Program means it's a set of the instruction. So that instruction will be called by the processor, CPU. CPU is the, as you know, the most important part. So when my daughter was the kindergarten, even she asked me what do you know what is the CPU? Then it's kind of brain of the it's like the brain in the computer. So it's the most important part that process the instruction. So it processes instruction by instruction. How can the processor CPU read and execute the instruction? If possible, we try to directly read such an instruction by instruction from the hard disk drive. But that's too slow. We will see why the processor cannot read the instruction directly from the program. Instead, we are going to use the memory. So that means we need to move such a set of instruction to the memory. That action event is called the execution of the program. Then that means you will create the process. How many process? So many process nowadays. There was the operating system that allow only one user process. Okay, which means one job, one program. Even though your operating system allow one user program, that doesn't mean there exists only one process in your operating system. Why? Even operating system itself need process. Just one process? No. As we have seen before, there's a kernel, the initial init process. That init process will create many system processes. So even though old fashion, the operating system allow only one user, one program, do you think we have such a system, operating system, allow only one user process? Well, one user program? Yes, embedded system. Embedded system, there's no way to execute your own code or your own program. That allow only one program. But that doesn't mean there is only one process. There might be several processes. Sometimes it's running background and you need to take care. You need to manage the limited resource. That is the purpose of the process management. Even nowadays, most of the modern operating system allow multitasking, which means there might be multi-user and each user also can run the several processes, job at the same time. So definitely we need to manage. As I said, if we have the unlimited resource in the computer, we don't have to worry about the process management. We don't have to worry about the memory management. Just allocate give the resource for the new process then they can run because we have unlimited resources. The problem is, unfortunately, it's not possible. It's even ideal case. So we do not have the unlimited resource. Within the limited resource, how can we maximize the usage of that? How can we will see the later, maximize the utilization and maximize the throughput and minimize what? Just something. Anyway, so we will minimize the response time. Okay, that's our goal. So in this chapter, we will talk about such a process management in terms of the concept, what is the process, and what is the scheduling. Scheduling means we want to share such a unlimited resource, okay, for multiple processes. How can we manage? So we are going to schedule such a multiple processes. And also we will see the separate the chapter for the scheduling part later, CPU scheduling, because that is one of the most important the algorithm used in the operating system. And in the process anyway, in terms of the computer architecture and the operating system architecture, process itself is data structure. So each system, computer architecture has a general structure of the process, and your compiler will follow such a data structure. That is the reason, even though you are using the same source file, but if you compile your program with the 32-bit, that is different from the 64-bit, because this system has different process data structure than rather than 64-bit data structure. Eventually, because the hardware itself, the CPU, handled that differently. So that and that time also processor needs such a data structure needs such operation for the management issue. Then definitely when you execute the multiple processes, each processor should be able to communicate each other. Nowadays there is no processor which can be running alone. Okay, it should communicate with other processes, system processes, or the children processes. How can they communicate? It's different from the TCP/IP protocol. It's an internet connection. It's the intercommunication method. That's called the inter-process communication, IPC. So IPC is the major communication method algorithm used in the operating system. Okay, so we will see some of the examples of the IPC system, Windows and Linux, and we will see also the client server that I think you guys are very familiar with. So like the socket program for such a CS environment. Okay. Also nowadays the thread is getting more important, so we will see details of the thread in the next chapter. So we will use we will little bit discuss about what that is, the thread. Then mainly we will talk about the thread and then later. So what is the process? It's a data structure. Before that, to design such a process data structure, so we should understand what is the definition of such a program or the process. In the batch system, sometimes the process is called the job. Okay? It's not exactly same meaning, equivalent meaning, but mostly if you indicate if you use your computer power for the batch system, which means usually not always in general, long running job, that is called a job sometimes, batch job or job and process. But if your system is like the kind of the very quick response time, like the online transaction system, at that time it's not called a job like that. Okay? So job and the process are sometimes used. They are used interchangeably. Most of such a case are the batch job, long running job. So for example, as you know, I'm teaching the NoSQL data, big data system. Your program, your process are called as the job. So we submit a job, which means we execute the process for such a big data processing. In the time shared system, it's called the task. Okay, so sometimes one job consists of the many tasks. Just like the process, you will see the what is the thread later. You execute the one program, one process that will create a multiple thread. Each thread is called task. Usually, in general, task is a part of the process job. Okay? It's not, however, it's not the clear the definition. Sometimes the task means your process itself, so it can be used interchangeably. It's not a big critical issues. So in this class, even in the textbook, we use the job and the process interchangeably. But if we need to clarify this is a job or the batch job or long running job, rather than the task, I will mention about that. But when I'm saying that creating job means creating process, okay? Meaning the job or scheduling job means scheduling process, okay? So process, as we discuss a lot, process is execution, program in execution, which means it's a set of instruction loaded into the memory, which means it's ready to be called by what? CPU processor. Okay? So we will see details of that. However, anyway, process in terms of the computing architecture is a data structure. That data structure consists of the several parts. Some of you guys already know that. First, I took the compiler course 20 years ago. The compiler course at the time we developed so throughout the semester we developed very simple language compiler, which is called the PCAT. I think it's a very simple program language. At the time, those who didn't have the knowledge about the data structure, especially the process, it's very hard to understand the concept of the compiler. In the compiler, even you should use process data structure. Why? The input of the compiler is a high-level source code that should be converted to the instruction. Not only just the instruction, that instruction feed to the memory structure. That memory structure means process structure. So which means, so if the main function is called, okay, the instruction, this is the memory. So 0 to FFFFF should reserve the certain area. For example, even your compiler should know what is the size of default process structure. For example, 32K. And the 0 to 32K will be reserved and define where is the area address to upload this. Not all the instruction to that. We will see we don't have to load all the instruction, instead of some part on demand. Okay? Because this part and part will not be used right now. Sometimes never used, depending on the use case. So this part will be used for the program instruction. This is called the first one, text section. Then from time to time it will be replaced by the next part if needed. Okay. Then you define the integer I. Integer I, the global variable. Global variable should be accessible by any thread, any point of your process, but not other process. This is the process B. Doesn't have to be the accessible to this part, but within same it should be accessible. You can put a certain area for global variable. Also, from time to time, when you process your algorithm, you need temporary resource storage of the area. Okay, that is heap area. Heap is going bottom to up, top to bottom. Which one? Bottom to up. Also, you have stack. Stack is top to bottom. Stack will be used for local variable. Local variable will be gone once that function, that loop, that part is completed. Okay, this will be defined in your compiler. Okay, so compiler should know everything about the data structure. Then, when this process, this source file is compiled, follow that structure and convert into the instruction. Then, when it's executed, load based on the such a rule. Okay, this part will be discussed the memory management later. So mainly it consists of the text area, okay, and also that part include the program counter. Program counter means this part will be accessed by the CPU. You have the CPU and you have the register. Okay, register is kind of, it's a storage. What kind of storage? Rest disk storage. Okay, so your CPU in one cycle, so your CPU can process the one set of the instruction that is in the register. Okay, that is one cycle. So you have the 2.6 gigahertz, which means hertz means is how many times. So wave, right? So per second it can process 2.6 gigatons of such a thing. Anyway, so register has the value sometimes, for example, I equal to 1. Okay, but if you execute the only one process, one job, one program in your operating system, you don't have to worry about the using the CPU resource, because this process is the only process that needs the CPU power. However, what if we have another process B, process A? Anyway, you need to share. Share means this process will use the CPU resource, which means that the data in the register should be replaced by one in process B. At that time, this is current. The CPU should remember where, for example, you have the series of instructions, so this is 100, and stop. Then process B, we will take over the CPU resource. Somebody should remember the current location of the execution that will be stored at the program counter. Okay? Also, that is saved in the PCB. Now, later we will see process control block. That is the program counter. It's a process register information. Then stack is the temporary area. Okay? Usually used for local variable or return address. It will be flushed out for reuse. Who is in charge of such a thing? Operating system. In your compiler, in your program, should have garbage collector. Okay? Garbage, not operating system. So garbage collector is a part of your programming, part of your compiler. So from time to time, the data in this part by your address will be flushed. Okay, that is the reason the local variable temporary area is located in the high address. Right? So if you put the temporary data lower part, so it cannot be compact, okay, or complicated. So that is the step area. And also we have the heap. Heap is the dynamic. From time to time, when you process a for loop, while loop, it's dynamically allocated. You need a memory, okay? So that will be used in the heap size. So for example, when you execute the Java object file, how can you execute the Java object file? Using click the button in the Eclipse. It's a Java command, JAVI. Java command, when you execute the Java command, that means it will execute Java virtual machine. Or sometimes it's called a runtime environment, JRE. So on top of Java virtual machine, your object file will be running. That is the reason Java said compile once, then that object file can be used anywhere as long as you have Java virtual machine. The command Java virtual machine should fit to your operating system. Then on top of that, your object file can be executed. So at that time, my object file need a lot of the space in the memory to process because it uses the memory data structure. Okay? At that time, there should be default size of your Java virtual machine. JVM is one process, and also it executes the object file. There's another process. Then we'll use Java virtual machine, especially for heap area. So you need to increase the heap size. So that's the reason if your object file Java program is running long time and needs more space, you can increase the memory size. Memory size means this dynamically allocated heap size in your Java virtual machine. That is the heap. All of this step heap and the program counter text section are data structure. In your program, you can change such a structure. Operating system provides such a data structure for process. So each operating system may have a little bit, sometimes huge, different process structure. This is general part of the process. Then we can say that compile the program, which means the instruction is called passive because it cannot do anything until it is called. And when it is called, which means executed, if they are in the memory, then they can do something. So that is the reason sometimes process is active and while the program itself is called passive. How can we execute the program? Using interface program. Sometimes it can be shared program. So using such a shared program, so Bourne shell, C shell, Cone shell, Bash shell, what else, the Perl. Using this kind of shell program, you can execute. Other way is in Windows-based system, so desktop environment, KDesktop in Unix, and Windows is a desktop, and you can click. That means it can execute. But what they are doing is just exactly the same thing. Just the different thing is the interface. Also, you can execute the Windows program using command line interface. You can by typing. So I mentioned many times. Everybody took the microprocessor or assembly language course. I think the CECS undergraduate student, I think must take. It's a core course, right? And if you are majored the computer engineering or engineering part, probably you took such a course, but some of the computer science program does not handle such a assembly code. This is assembly code. Okay, if you compile this is a hello world in C program, right? Very simple. So integer I and I equal 10, print f, I is 10. 10 is, I is 10. That's it. You can compile using the GCC or whatever. Then this is the list of series of the instruction. Okay, this part is the main part. So you can slightly understand. So for example, say there's something registered information to where the address, something like that. It's very hard to manually convert the code of this one. However, when you develop this compiler program, definitely you should know this kind of thing. Then this programming, the instruction will be loaded into this part. This slide shows a very high level data structure of the process. So consists of the text, data. Did I touch this one? I don't think so. I did not. The text and data, heap, and stack part. Any questions so far?
Yes.
Yes.
What's the space between the heap and stack?
Then it will be heap is if you need when you create the first time the process, there's only the predefined address starting point the heap, then we go this way. Okay? And also temporary data, the stack will go from top to bottom. For example, if your size of process 32K this way. But what if you need more space? At that time, you can there is in your compiler you can the design what is the next chunk of the process. That time it can have some pointer to the other chunk of the memory. Okay, then you can increase the size of the process if needed. And also the stack part is from time to time will be flushed out using garbage collector. Some of the languages are doing the automatic the garbage collector. Otherwise, you need to run the garbage collector function or module from time to time. What about the Java nowadays? Do you need to run the garbage collector? I did when I learned the 1.4, 1.5. So is that okay? And even though there is an automatic garbage collector in your program, it's also a good idea if you believe there's something wrong. But I think probably okay. So if you want to flush out the memory, the stack area, you can run the garbage collector by yourself. Java provides such a thing. Because I used one time the Java program to process a video data. So video has a lot of the streaming data. So for example, in a second there might be 60 frames per second. Each frame has the 1080 by 800 pixel, which means it's at least the 60, 70 megabyte for each frame. So I allocate a very large the Java virtual machine, but if before the garbage collector flushed out the temporary data, sometimes I need to use the next frame is processed. So I learned before I move to the next frame, I code the garbage collector, then I can process. First time I just increased the heap size, whatever, but it didn't work. So there are different states of the process. So process, so far I mentioned the execution. Execution means just load it into memory, that's it. Then it will be called by the CPU. No, you have the many processes in your memory. So, unfortunately, CPU can handle only one of these. This is the CPU time. So CPU time, how many processes can handle? Only one. But you can be smart, you can share the CPU time. But anyway, the physical CPU time will not be changing. So 0 to 100. Right? So can you make another CPU time? Even though you have the perfect CPU scheduling algorithm or whatever, so you cannot increase the physical time of the CPU. Instead, you can be smart to share the time. So it's a time sharing. Okay, so how we can share such a CPU time? To understand that, in your instruction, of the code, actually, it's not only the process in the register. Sometimes it need to get the data I, okay? Or sometimes you can open the file, especially. In this case, there is no open file, then read the data. But somewhere, for example, if you get the data I from the file, so you need to open the file using fopen system code. Then read the system code, then get it. So at that time, what can CPU do? What can the CPU do? After this CPU called the read data I from the file A. Nothing. There's nothing CPU can do. While after CPU called the read the data from the file, should wait until actually this CPU called the interrupt signal. Send the signal to the disk controller. Okay. Then disk controller understand the file, the A. Okay. Then data I. It will be changed into the cylinder number. What S? Sector number. Okay. Then finally find the data and return it and forward. It takes a time. It's much longer than CPU process time. Okay? Usually 2.76 gigahertz per second, but what about this one? Take 1 second. 1 second is huge difference. So during such a time, CPU cannot do anything. So why don't we use that time? So instead of waiting of such a input and output, call another process. So this is a process A, this is a process B, and process A is called the IO wait. IO then wait. During